A retired VW powertrain engineer told me something over coffee last spring that I haven't been able to shake. He stirred his cup, looked at the table for a long moment, and then he said the E8888's oil consumption was discussed in internal meetings before the engine ever shipped. They knew. They had a number for it. They shipped anyway. He wasn't bitter about it. Not exactly. He talked about it the way a doctor talks about a patient he couldn't save. The 2.0T TSI he helped develop is sitting in driveways right now, quietly drinking a quart of oil every 2,000 or 3,000 miles, and most of those owners have been told by a service writer that it's perfectly normal. That conversation is why I'm doing this today. So let me set the table for you, because this matters whether you own one of these cars or you're shopping for a used Audi or Volkswagen with a 2.0T badge on the back. We're talking about the E888 engine, specifically the first and second generations, which powered an enormous slice of the VW and Audi lineup from roughly 2008 through 2014. Tiguan, CC, Passat, GTI, Jetta, Audi A4, A5, Q5, and the TT. If you owned a Volkswagen or Audi turbocharged 4-cylinder in that window, there's a good chance you owned this engine, and there's a meaningful chance you experienced what owners describe as elevated oil consumption. The pattern is consistent. The car drives fine. Power feels normal. No smoke you can really see in the mirror. But around 3,000 miles into an oil change, the dipstick reads low. By 4,000, it's a quart down. By 5,000, you're staring at a warning light and wondering what you did wrong. The answer, according to the engineer I spoke with and according to a body of class action records, is probably nothing. You didn't do anything wrong. The engine was designed in a way that, under real-world driving, can cause exactly this. But here's where it gets interesting. The story behind why the engine was designed that way is not a story of negligence. It's a story of competing priorities inside an engineering department, and the priority that lost was the one most owners care about most. Let me tell you about the source, because credibility matters on a topic like this. The man I spoke with spent more than 2 decades working on powertrain calibration and mechanical durability for a major European OEM, with direct involvement on turbocharged gasoline programs that overlapped the EA888 development timeline. He retired some years ago. He asked me not to name him, and I'm honoring that because what he shared was an account, not a sworn statement. I'm not litigating fault here. I'm telling you what an insider with relevant experience said about how engines like this came to be the way they are. And it's worth saying that he isn't the only voice on this. There's a well-documented class action settlement involving certain 2.0T TSI vehicles and oil consumption claims. The settlement was reached without an admission of wrongdoing by Volkswagen, which is standard, but the existence of the settlement, the eligibility criteria, and the remedies offered tell you something on their own. Class action records show that affected vehicles received extended coverage tied to a specific consumption test, with reimbursement provisions for owners who had paid out of pocket for related work. Engineering analysis indicates the issue was real enough, common enough, and reproducible enough to drive that kind of corporate response. Wait until you hear what the engineer described as the internal trade-off, because once you understand it, the dipstick story makes complete sense. Here's the technical heart of it, and I'm going to use plain language because this is the part that most YouTube explainers either skip or scramble. There are 3 design choices that, working together, can cause an E888 Gen 1 or Gen 2 to burn measurable amounts of oil under normal driving. Take them one at a time. The first is the oil control ring. Every piston in every gasoline engine has rings around it. The bottom ring, the oil control ring, has one job. It scrapes excess oil off the cylinder wall on the way down and lets a microscopic film remain so the next stroke isn't dragging metal on dry metal. Think of it like a squeegee on a wet window. A stiff squeegee, pressed hard, leaves the glass nearly dry. A soft squeegee, with light pressure, leaves streaks. VW engineers, chasing better fuel economy and lower internal friction, specified what the industry calls a low-tension oil control ring. Less spring force pushing the ring against the cylinder wall, less drag, better miles per gallon on the test cycle. The trade-off, and this is the part the engineer said was discussed openly inside the company, is that a softer squeegee leaves more oil behind. That oil then sits on the cylinder wall during the power stroke, and a small portion of it can be consumed in combustion. Multiply that by 4 cylinders and thousands of cycles per minute, and the math shows up on your dipstick. Most people don't know this, but the oil control ring on a modern engine is one of the most consequential parts in the entire machine for both fuel economy and oil consumption. It's a piece of metal smaller than a wedding ring, and it decides whether you stop at the gas station for fuel or for a quart of oil. The engineer told me the team had projections for how much oil consumption the low-tension ring would generate. He didn't quote me a number across the table, but he said the projection was, quote, within what marketing could defend. That phrasing stuck with me. Within what marketing could defend. The The second design choice is the piston itself, specifically the orientation of the oil drain slots that sit behind the oil control ring. On a piston behind the oil control ring, there are little drainage holes, or slots that let scraped oil flow back down into the crankcase rather than pooling up in the ring groove. On the early E8888, evidence suggests the slot design and orientation didn't drain oil away from the ring as effectively as the redesigned later parts did, so oil could accumulate where it shouldn't, and once it accumulated, it had nowhere to go but past the rings on the next stroke. Imagine a kitchen sink with the drain partially blocked. Water rises. Eventually it spills over the edge. Same principle, on a much smaller scale, every few milliseconds, while you drive to the grocery store. This part will make you check your dipstick before your next fill-up, because the third design choice is the one most owners never think about. It's the PCV system. PCV stands for positive crankcase ventilation, and it's the engine's way of relieving the pressure that builds up inside the crankcase as the pistons move. Combustion gases sneak past the rings into the crankcase. That pressure has to go somewhere, or it'll blow seals out. So a PCV system vents that pressure back into the intake to be burned off. The trouble is that the gases coming out of the crankcase are full of oil mist, and the PCV system has to separate the oil from the air before sending the air back into the intake. The early EA888's PCV oil separator, by multiple accounts, and by the volume of failed part claims in the aftermarket, didn't separate as well as it needed to over the engine's lifetime. The diaphragm inside can fatigue. The flow paths can let oil mist through. The real-world consequence is that, in addition to oil being burned past the rings inside the cylinder, oil mist can be sucked through the intake and burned in the combustion chamber from the other direction. Some owners report two sources of consumption stacking on top of each other. The squeegee leaves film on the wall, and the ventilation system delivers a second helping through the intake valves. There's the technical formula in plain English. A low-friction ring leaves a thicker oil film, which means more oil reaches the combustion chamber, which means a quart can disappear over a few thousand miles, which matters because most owners assume their engine is failing when in fact it's behaving the way the parts were shaped to behave. Pay attention to this number, because it's the one I want you to remember from this whole conversation. In the class action settlement context, the threshold that triggered remedies was tied to consumption greater than 1 quart per 2,000 miles, measured under a specific test protocol with the engine warmed up and the vehicle driven a certain way. 2,000 miles per quart. Think about that. If you drive 15,000 miles a year, that's 7.5 extra quarts beyond what's in the pan. Almost 2 extra oil changes worth just gone, somewhere between the cap and the catalytic converter. And that's not even the worst part. The worst part is what some owners report happens when oil burning isn't caught and topped off in time. The catalytic converter sits downstream of the combustion chamber. When oil gets burned with the fuel, the byproducts include phosphorus and zinc compounds that can coat the active surface inside the cat. Engineering analysis indicates that prolonged elevated oil consumption may have contributed to premature catalytic converter degradation in some affected vehicles. Catalysts aren't cheap, so a problem that started as a few molecules of oil sneaking past a soft ring can end as a check engine light and a 4-figure repair bill. You can smell it sometimes. After a spirited drive, when the engine bay is hot, there's a warm, sweet odor that drifts up from the front of the car. That's oil contacting hot metal somewhere, often the catalyst or the turbocharger housing. You can hear it too if you know what to listen for. The soft tick of an E888 at idle when the oil level's down is just slightly different than when it's full. It's a hair sharper. And if you start the engine after it's been sitting hot for 10 minutes, watch the mirror for a brief blue puff on the restart. That's oil that pooled past a valve guide or settled into the combustion chamber, burning off in the first revolutions. Now, let's talk about the conflict, because this is where the story gets genuinely uncomfortable. For years, the official position for many VW dealerships and service centers, citing internal guidance, was that oil consumption up to roughly 1 quart per 1,000 miles was within specification. 1 quart per 1,000 miles. That's the manufacturer's stated normal range, and it was repeated to owners again and again when they came in concerned about a low dipstick. The phrasing was consistent. This is normal consumption. The engine is operating as designed. And here's the thing. From a certain narrow legal and engineering standpoint, that statement isn't false. The engine is operating as designed. The trouble is that the design itself, according to the insider account I'm relaying, and according to the body of class action evidence, was a compromise that prioritized friction reduction and emissions over crankcase oil retention. The engineer told me, almost word for word, that the durability team and the fuel economy team had different definitions of acceptable. The fuel economy team won the early rounds. The durability team won the rematch, which we'll get to in a minute. So owners were told their cars were normal. Owners pushed back. Some owners report being asked to bring the car in. For a consumption test, where the dealer would mark the oil, send them out for a set number of miles, and then measure how much oil had been lost. If the loss exceeded a threshold, the dealer might recommend further work, including in some cases a piston and ring replacement. If the loss was just under the threshold, the answer was, again, normal consumption. But here's where it gets interesting. The replacement parts VW eventually used for those repairs were not the same parts that came in the engine from the factory. The piston design was revised. The ring set was revised. In some cases, the PCV components were revised. That tells you everything you need to know about whether the original design was operating as intended, because if the original was fine, why would the replacement be different? The Gen 3 EA888, which started rolling out around 2013 to 2014 depending on the application, addressed these issues directly in the new production. Revised pistons, revised rings, revised PCV oil separator, repositioned crankcase ventilation paths. Engineering analysis indicates that oil consumption on the Gen 3 platform dropped substantially compared to the Gen 1, and Gen 2 it replaced, which is the strongest non-admission admission you'll ever see from an automaker. They didn't say the old engine had a flaw, they just shipped a new engine that didn't have the flaw. So what does this mean for you today in the real world? Let's get practical. The advice that follows is general guidance based on the patterns owners and independent technicians have described. Your specific car, your specific mileage, and your specific driving conditions will vary, and a qualified mechanic who can actually look at your engine is always the right answer for diagnosis. If you own a 2008 to 2014 VW or Audi with a 2.0 T TSI, and you don't already know whether you've got a Gen 1, Gen 2, or Gen 3, that's your first homework. Your VIN and your build date can tell you, and a quick lookup with the engine code will narrow it down further. The relevant codes are CCTA, CBFA, CAEB, CCZA, and a few others. If you're inside the Gen 1 or Gen 2 window, you're in the affected family, even if your particular car has never shown elevated consumption. Then, regardless of how the car has behaved in the past, start treating the oil level the way diabetics treat blood sugar. Check it. Check it often. Check it cold on level ground, with the engine off long enough for the oil to drain back to the pan. Every other fill-up at minimum. Once a week if you drive a lot. If you find the level dropping between scheduled oil changes, top it off with the correct VW specification oil. For most of these engines, that's a 5020 approved 5W40 or 5W30 synthetic, depending on the year. And do you want to verify the spec stamped on your filler cap before you buy a bottle? Keep a quart in the trunk. This is not paranoia. This is matching your maintenance to how the engine actually behaves. If your consumption looks elevated, document it. Write down the mileage when you top off and how much you added. 2 or 3 data points across a few thousand miles will tell you a lot. If the pattern shows more than roughly 1 quart per 2,000 miles, that's the historic threshold that mattered in the settlement era, and it's a reasonable trigger to have a deeper conversation with a qualified independent VW specialist about whether a consumption test or further inspection is warranted. Avoid extending your oil change interval past 5,000 miles on these engines, even if your service light is set for longer. The long life intervals that VW marketed during this generation were optimized for a different set of priorities, and an engine that's losing oil between changes is an engine that doesn't have the margin for a 10,000 mile interval. 5,000 miles, fresh oil, the right specification, the right filter, that's the safe envelope. Some independent technicians recommend even shorter intervals in the 3,000 to 4,000 range for vehicles already showing elevated consumption. Look at your PCV components. If you've never replaced the PCV valve assembly on a Gen 1 or Gen 2 EA888, and you're past, say, 80,000 miles, it's a service item that has paid dividends for a lot of owners. The part isn't expensive, the labor is moderate. A failing PCV diaphragm can show up as elevated oil consumption, a whistling sound at idle or rough running when cold. Replacing it doesn't cure the ring design contribution to consumption, but it eliminates one of the 2 pathways. Mind your driving style during the first 10 minutes of a cold start. Short, low-load trips don't let the rings expand fully and can let more oil sneak past on a cold engine. If most of your driving is short hops to the store and back, the engine never reaches the operating temperature where its tolerances close up properly. A weekly highway run of 20 or 30 minutes where the engine reaches full temperature under steady load is genuinely good for these engines. Think of it as cardio for the rings. If you're shopping for a used 2.0 T TSI right now, factor all of this in. Ask the seller for oil change records. Ask if oil has been added between changes. Pull the dipstick yourself and look at the color and level. Listen at idle for that soft, sharp tick. Watch the exhaust on a cold start and on a hot restart. None of these checks are deal breakers on their own. All of them together tell you a story. Here's the F, then. I want you to keep in your head. If you own one of these engines and you drive it more than 10,000 miles a year, then you need a quart of approved oil in your trunk and a habit of checking the dipstick every 2 weeks. If you've been told your consumption is normal, but you're putting in more than 1 quart between 5,000 mile changes, then it's worth a second opinion from an independent VW specialist who has seen these engines for years. If you're past the original extended warranty window and your car is showing elevated consumption, with no documented history of remedy, then your decision about further work is a cost-benefit question that depends on the rest of the car's condition. But ignoring it usually costs more in the long run than addressing it. And if you haven't checked your oil this week, do it tonight. Park on level ground, let it sit, pull the dipstick, wipe it, push it back, pull it again, and look. The dipstick line that's a quart low after 3,000 miles is